This recording will be a review of what we did last week with monatomic ions, that is, ions made of just one atom, and then we're going to move on to doing polyatomic ions. So don't be scared of that big name, but here's how it's all going to work. So we're going to start with this guy right here, and let's see what we were supposed to do. We were supposed to put them together, more or less in the way that we did last week. I cut it a little bit short, but first of all we have to determine what are the charges. So we look at the column that the atom is in, and that will tell us what charge will be on his ion. So the crisscross was all about taking the charge from one ion and making it the subscript of the other ion. And we did that alternately for the phosphorus and then for the aluminum. The next thing we want to do is see when we put this together. Notice the negative did not come down. Negatives do not show up in subscripts. So the subscripts are just numbers. They have no plus or minus sign with them. When we go to put that thing together, because this is not the smallest ratio that we can have of the subscripts, we make it just AlPi, and we name that aluminum phosphide. This guy, I'm going to go a little faster. Magnesium's in column 2, arsenic is in column 3, and column 3 is a 3 minus, and column 2 is a 2 plus. We crisscross the charges, drop the plus and the minus, and then we get magnesium with 3 as a subscript, and arsenic as 2 with a subscript. Then we go ahead and write the correct formula, which is this, and then we call that magnesium arsenide. Notice that the IDE ending is the name of the second atom, which will always be the negative atom, and it will have an IDE, like phosphorus becomes phosphide, arsenic becomes arsenide. And the last one that we did was sodium with sulfur, and when we crisscross those after finding out their charges, we find that sodium is going to have a subscript of 2 and sulfur will have a subscript of 1, which we don't write in the actual formula for the ion, or for the ionic compound. And then the next thing we do is name him with the name of the metal first, because the metal will always be a positive ion and positive ions always come first, and sulfide, IDE, instead of sulfur. Okay, so read this, stop the recording if you missed class, and read this, because this is important information. Next, we went on to combining polyatomic ions. We had a handout today that allows us to get the charge of the ions, and that handout looks like this. This is just the center section, and in the center section you will see the charges of all the ions that we'll be dealing with. You notice the positive ions are in this column, the +2 ions are -2, -1, -2, and -3. They're grouped that way and it makes them easier to find. And then you see the names of the ion, which we're going to use in the naming of the ions for the compounds. So we're going to go back now and look at where we were starting out. So as you see here on the screen, it says treat atomic ions just like single atoms have been treated up to now. So in the crisscross, I am showing you a green and a red. The green is one ion. It's a polyatomic, which means it has more than one kind of atom. And then the other one is a red polyatomic. And you can see that this red guy is representing also a polyatomic ion. And we do the crisscross with polyatomics just like we do with the monatomic guys that we did before. So now you see the ratio from here down to here and here down to here, dropping the charges, is a 2-to-1 ratio. Then we go ahead and write the molecule just like we did before. This should look familiar, okay? And so now after we have that, we're going to name the compound. And as you're going to see, this compound is going to be ammonium sulfate. So why don't you stop the recording and find ammonium sulfate in that second handout that gives you all those names. And look at the formula, or look at what those ions are made out of. And I'm going to cover this back up again, and we'll go back and do it as the actual ions. So we're going to do, first of all, ammonium. Now see if you can find that on the chart. Okay, you'll see ammonium ion up here, and that's how you can find that guy. Now this is the sulfate ion, and the sulfate ion is SO4 2-, where the ammonium ion over here is NH4 1+. So now we go back, and we're going to do just what we did before, only we're going to see all the jumble of letters and numbers. But it's all still just like as if it were one atom. The big deal that is going to happen with these guys is we're going to be using parentheses, which we didn't need before. And you'll see why we use parentheses when, like for here on this ammonium dude. You see I wrote the ammonium ion over there, but I didn't put a charge with it. So I'm going to say that we have 2 of these ammonium ions. Well, that looks pretty weird. It looks as if there's 42 hydrogen atoms in that molecule. No way. And if we use this literally, it's just not going to make any sense. But it does make sense when we do this. We put the parenthesis around the ammonium ion, and we say that there are 2 of them. Now it makes much more sense. And same thing would be with the sulfate. Okay, when I use the sulfate down here, I'm doing the crisscross, so I have the 1 down there. I would have the same problem with that. But we are showing this in a way that will allow you to see a difference when we get to the next step. So we go over here, and we look at the final formula, and that's NH4. There's 2 of them, and we saw that right here. And we needed that parenthesis to make it make sense. And then we have the sulfate. Notice down here I needed a 1, but over here I don't put the 1, and so there was no need for the parenthesis. And we just name this the names of the 2 ions. It's so simple with these polyatomics. So this is the ammonium sulfate, and that is the name of the compound. Okay, let's try another. I'm just going to go real fast with this. We know that the nitrate is going to have a 2 subscript, and we know that calcium will have a 1 subscript when we do the crisscross. So we write them like that, and then we go down a little bit further and actually put them together without the 1 subscript of the calcium. And we have to have that parenthesis so that the 2 makes sense with the nitrate. And that's all there is to that guy. This would be named calcium nitrate. We don't say dinitrate, even though there's 2 of them, because nitrate can only have 1 charge and calcium can only have 1 charge, so we don't use prefixes. As we go on to the next one, we are going to see the rubidium with acetate, and you can find those on your chart. You can pause the recording and look for those. So this would be rubidium and acetate ions. And when we put that together, because their charges are the same but opposite, when we do the subscripts, everything works great, and we have something that we call rubidium nitrate. Okay, so now here we have the paper that we're actually going to be working on. So this is how we're going to put things together. You'll see you have the charges of all these guys, but you don't have the names. And that's what you get off the other paper that I handed out today that I was just showing you earlier, this guy. That'll show you exactly what it is that's going to be happening so far as getting the names when you go to name them. All right, so let's do it. Here we have magnesium, and we're going to mix it with nitrate. So we're going to have 2 nitrates, because NO3, because magnesium has a charge of 2. So we're going to need the parentheses, and we're going to put the 2 in there as a subscript. Okay? And that's how that goes. Now we have to name that guy. So we use the name of the metal just like we did before, and notice that the positive ions are always going to come first. And then we say nitrate, magnesium nitrate, and this is A1, and we're going to bring that down to here, and so we have magnesium. Oops, I'm writing the symbols. Not good. Okay, that's magnesium. M-A-G-N-E-S-I-U-M, nitrate. And that's N, nitrate, N-I-T-R-A-T-E. Okay, and then we're going to our next one. Let's try another one. We'll do ammonium, and we'll do acetate. Boy, that's a big one. Okay, that's going to go together very easily, though. So here we go. We're going to put ammonium, NH4, and acetate. Oh, and look. Here we see a 1 and a 1. So when we put those guys together, all we have to do is have one of each. And so the ammonium doesn't need a parenthesis, and we just write in the acetate, C2H3O2. One of each. All right, the next thing that I'd like to do for you, we better write that in. Where's that going to go? It's going to go down in C3. And C3 we will see down here a little bit lower, and that's going to be ammonium. Ammonium acetate. Okay, so the last example I'm going to give you, and that should have you flying pretty well. Let's do this guy in black. Let's do it in red. So we'll do calcium, and let's put him with sulfate. So calcium and sulfate, they each have the same charge, CaSO4, and so there's no need for any subscripts, no parentheses, no nothing. This was a nice, easy one. So E6 is where I'm going to have to put him, and E6 is down here, and so we put in calcium, CaLCium. Let's rewrite that. That was pretty bad. CaLCium, and sulfate, SULFATE. Your assignment tonight is to do all of these guys and fill that chart and fill it with names down below and the formulas up above, and that is what you're doing. I hope you find this very helpful, especially if you've been absent. I think this will make life a lot easier for you. So thank you for watching.